Recording in progress.
Yep, comes on everyone. Let's start off. The last thing we have completed with the projectile motion. Today we'll be starting off with relative motion. Chalo, others comes on. One second. Okay, great. Chalo, let's start off. So we'll be starting off with relative motion. Now, in certain cases, it's more convenient. What is happening? This pen today. It is convenient to solve with respect to a moving frame. Now, what do you mean by this? Now, see, till now in kinematics, right, whatever we have solved in 1D and 2D and everything, we were always doing it from the ground frame. In the beginning, if you remember, we discussed this thing as an inertial frame. Now, for example, let me give an example. How does this thing make easy? For example, if I ask you this, how does the moon move with respect to the sun? If you're standing on sun and if you look at the moon, can you tell me how will the path look like? If I ask you to study the motion of a moon with respect to the sun, how do you think the path would look like? Just let me take back indents. It would be pretty weird. It would look something like this. So the sun is here. This moon would be going something like this, like a jalebi. Quite a complex path. But suppose the same thing, if I ask you like this, let's study the motion of the moon. Or let's say, first let's study motion of Earth with respect to sun. So stand on the sun and look at the Earth ka position. Then go to Earth and then look at the moon ka position. So if you ask you this question, same thing. With respect to sun, where is the earth? Approximately earth goes in a circle. So we can be sure the earth is somewhere on this circle. Now, if I ask you where is the moon with respect to the earth, you can be sure it is actually another circle. Is this making sense? So the motion of the moon is actually a combination of two circles. So if you try to suddenly, start doing it directly, it becomes very complex. But suddenly when I start studying the motion with respect to earth, it kind of becomes easy. This motion is nothing but combination of two circles. Is this making sense to everyone? So it is more convenient to study the motion of the moon with respect to earth and then look at the moon from the sun curve frame than directly looking at the moon from the sun curve frame, which becomes quite complex. And if you think about it, this is what we have been doing from the projectile motion. In projectile motion, when this thing is going at an angle, we didn't know what to do. We studied this motion as what? One vertical motion and horizontal motion, isn't it? We always split the motion into the simplest of the components and then we try to study them. Meaning, if I give you one more example, how does your fan inside the lift go? If you look at the motion of your fan inside a lift, if you see inside the lift, the fan is going in a circle and your lift itself is going in a vertical thing. So the combination of these two is actually a spiral, isn't it? So the fan inside your lift, when it is going up and down, is actually a spiral, which is complex to study. But if you try to do like this, with respect to the lift, means if you stand inside the lift, you will see a circle, and you yourself is going in a straight line. So it's a combination of a straight line plus a circle. I hope this is making sense. So in certain cases, right, it becomes quite easy to solve with respect to the moving frame, right? So let's see. So how do we study this thing then? So it is clear that studying with respect to a moving frame make things better. So we study relative motion by subtracting velocity and acceleration vectors of the observer from everyone. Now, what do you mean by this? This thing, right? This concept comes from a straightforward shifting of origin. Let's say if I have a point 3, 4, let's say this is origin 0, 0, and let's say this point is 5, 7. So if I want to shift my origin to 3, 4, what should I do? I hope you studied this in maths. If I want to shift my origin to 3, 4, what should I do? What will happen to the other coordinates? So this is what we do actually. If you want to shift to the origin to 3, 4, subtract -3, -4 from every one. When you do this, this guy will become the new origin, 0, 0, and the old origin becomes -3, -4, and this point 5, 7 becomes 5 -3, 2, and 7 minus 3. Is this making sense? This is how you shift an origin to a new coordinates. So if you want to make 3, 4 as a new origin, this is what you do. You take the 3, 4 coordinates and you subtract the x coordinate and y coordinate from everyone. Getting it? The same way, meaning if I give you a more crude example, think about this thing. Let's say, right, Vihan has 1 crore with him. He's pretty rich. Now, how to make him a poor person? Now, most common answer is to take away 1 crore for him. So we don't want, to do that. What else can we do? Give everyone else 10 crores, no? Because poor or rich is what relative, isn't it? Now he's become poor because you all are rich. So it is always relative. Getting it? So this is what we do in this. Let's say we have 3 people here. Again, I'm going to teach you everything qualitatively, and then we will see little mathematically. So with pictures, we can figure out what is happening. That would make things more clear. So let's say we have a point A here who is at rest. So this is speed UB, and this is the acceleration AB. This is UC, and this is AC. So now we want to study with respect to B. Now it's your choice. You can study with respect to anyone. So if you want to study with respect to B, what should we do? So this is A, B, C. This guy is going with UB. This guy is going with AB. This guy is going with UC, and this guy is going with AC. So this is what we do. We subtract B ka velocity UB from everyone, including B himself. We subtract the acceleration of B from everyone, including B. And now B will think, now if you see B ka velocity got cancelled, acceleration got cancelled. B will think, okay, I came to rest. I'm not moving anymore. But now I will think this person A is actually going backward with UB and going back with an acceleration AB. And this person C is going front with UC minus UB and acceleration AC minus AB. This is what B thinks about A and C now. So these are the velocities and accelerations with respect to B. This is exactly same thing as shifting of origin. You take B ka velocity and B ka acceleration, subtract from everyone. So B will come to rest. So he is your new origin or new ground frame, and everyone else ka speeds and accelerations have changed. And once you got this, then we just use your regular kinematics and solve. So the only new thing you'll be learning in this chapter, right, in relative motion is subtracting the velocity and acceleration. After that, it is your same 1D, same projectile, everything will be same. I'll show you that. But is this logic making sense, everyone? Have a look at this. Let me give you one more example. Clear? Now, let me take one more example. This is U1. This is theta 1. Let's say this is point A. This is U2, and this is theta 2. So I want to study the motion of, let's say, A with respect to B. Okay, two projectile motions. So let's say this thing also has a gravity G and this thing also has gravity G. So step one, resolve them into components. So this guy is U1 cos theta 1. This guy is U1 sin theta 1. This guy is U2 cos theta 2. This guy U2 sin theta 2. Acceleration is G and acceleration is G. This is B and this is A. Now we want to study with respect to B. So again, the same story. When you say with respect to B, you take B ka velocity. So what is this? U2 cos theta 2 backward. Now I have to do the same thing for A also. If you're adding to the right side, here also I have to add it to the right side. So U2 sin theta 2 downward. So here also I have to add U2 sin theta 2 downward. I have to cancel the gravity also, g upward. So this also is g upward. Are you getting what I'm doing? Whatever is a cap velocity, I cap, j cap, you reverse that and give it to everyone. And when I do this is what happens. B thinks I'm at rest, everything got cancelled, velocity got cancelled, acceleration got cancelled. But now this person A is going upward with u1 sine theta 1 minus u2 sine theta 2. And this thing is u2 cos theta u1 cos theta 1 plus u2 cos theta 2. Right? And what is the acceleration? 0. Acceleration got cancelled. So A relative is 0. Acceleration of A with respect to B. So now, B will think A is going in a straight line like this. So this red line here is the path of A as seen by B. You're getting it? Normally, if you see this thing, right, A is going in a curve, B is going in a curve, both are actually going into parabolas. But when you stand on B and look at A, it suddenly starts looking like it's a straight line. That is because the acceleration got cancelled, and this will be the velocities there. So this is a important statement here. So B thinks A is going with constant velocity. So this is a theoretical question there, statement question. The motion of one projectile with respect to another projectile is always a straight line. There, please have a look at this example. See, I showed you an example in one dimensional, everything is going in a line. We can even do the same concept in two dimensional also. The only idea that you learned here is if you want to study with respect to B, take B ka velocity, I cap, J cap, acceleration, subtract. You want to study with respect to some D, take its velocity, subtract. That's it. That is the only straightforward thing. Once you subtract this, the question actually becomes easy because here you have to study two people. Here you just have to study one person. This guy is anyway at rest. But this becomes your regular kinematics question. Please have a look at this example.
Sir.
Yeah.
Sir, in that with respect to B part, the second one.
Which this one?
That U2 sine theta 2. Sir, would both of them be U2? No, sir, that is the next page. Yes, sir, in this one with respect to B part. Put, sir, this left side.
Yeah.
Sir, in the second
this
one.
This one.
No, sir, in the left side.
Okay.
Sir, yes, that. So, sir, both of the green and red would be U2 only.
Yeah. Array, you want to cancel which one? You want to cancel B, right? You want to bring whom to rest? You want to bring B to rest, right?
Yes, sir, I got it.
So whom should you subtract then? You should subtract B ka velocities only.
Yes, sir.
So if you want to cancel U2 sine theta 2, shouldn't you subtract that with the U2 sine theta 2? I should do the same thing for everyone, right? That's what I'm saying. If you're subtracting, subtract the same thing from everyone. Whenever you get confused, think of this concept. That's why I told you that shifting of origin. If you want to shift 3,4 to origin, and this point is 7,8. If I make this point origin, what are the new coordinates of 7,8? You subtract -3 -4, subtract -3 -4, isn't it? This becomes the origin, and this becomes 4,4, isn't it? Getting it? So whoever you're trying to stop, take his velocity, take his acceleration, and subtract.
Yes, about it.
Yeah?
Yes.
Any doubts on this page? No. So velocity of A with respect to B. So like I said just now, this is how we represent this. So this is how we call it VAB. So we can say VAB is VAG minus VBG. So G is nothing but the ground frame. So we can write this thing as, so velocity of A with respect to B is velocity of A with respect to ground minus velocity of B with respect to ground. So this can be also written as velocity of A with respect to ground is velocity of A with respect to B. I'm just shifting it that side. Velocity of B with respect to ground. Think of that example. Velocity of moon with respect to sun is velocity of moon with respect to earth plus velocity of earth with respect to sun. Getting it? So you just split the motion into two parts. Same way, you can do the same thing for acceleration also. So acceleration of A with respect to B. So someone writes like this, A subscript A comma B. You're simply saying this is acceleration with respect to B. So this also would be acceleration of A with respect to ground minus acceleration of B with respect to ground. So here I'm showing you in a symbolic form, but the same thing I was showing you here with pictures, isn't it? Subtracting it, I'm showing with a picture. So this and this are not different. This is a symbolic form of showing it. This is a pictorial form of showing it. Pictures are more easy to observe. Symbolic form is fine, but sometimes you don't get an idea what is happening. So once we got this, so we can use all your regular kinematics. So V relative would be D position vector. So normally what is velocity? dr by dt. So here it is d relative by dt. And A relative is dv relative by dt. So this would be V relative, dv relative by dr relative. Basically everywhere you just add the word relative, all formulas work. That means if your relative acceleration is constant, I can use my three kinematics equations. So you get back to everything, same thing. So V relative, U relative plus A relative into time. S relative, U relative time plus half A relative t square. And V relative square minus U relative square is 2A relative S relative, meaning you can use your entire kinematics for things. Please have a look at this. Yeah. Next thing. So the steps to follow. The steps to follow while solving the relative motion. The steps to solve. Step 1, choose your reference frame. So that's your observer. Now this is how do you know which one to take? It's your call. You can choose anyone you want. Second thing, subtract velocity and acceleration vectors. Same thing, whatever I told, I'm just putting it in a form of the observer from everyone. From every system, that is including the observer. Now what happens? Now when you do this, now the observer will suddenly start behaving like a fixed point. At rest. So this is the only new thing. Once you've done this, then use kinematics equation to solve. Now, how do you know that you have to use a relative motion? So sometimes you get a doubt like, sir, how do you know it's a relative motion problem? The idea is this, think about it. Till now in all the problems we did, how were the questions? A particle is thrown, find h max. A particle is thrown, find range. A particle is thrown, find time of flight. If you observe here, we are always interested in one particle. Rarely we studied about 2-3 particles. So generally, if there are multiple bodies, now this is not a concept, but an observation. When you do a lot of problems, you'll start getting this kind of, it's like more like an experience, it's time now, mostly there'll be relative motion. If multiple bodies are involved, right, and we are interested in motion between them, generally it's a relative motion. Let's see, we'll do a few numericals, that thing will make things clear. There, please have a look at the steps. Clear, everyone? Let's see a question. So let's say we have two trains. Train A is going with 72 kilometers per hour. There is another train B on the same track, which is going with 36 kilometers per hour. A pretty common thing in our Mumbai locals. They're going on the same track, and for some reason, the train in the front is slowing down, the train behind is going fast. So two trains, A and B, on same track are moving with 72 kilometers per hour and 36 kilometers per hour as shown. So when the distance between them is 1 kilometer, A realizes, oh shit, there's a train in front, and he applies brakes. And the B realizes, oh, there's a train coming from behind, and this guy starts accelerating with A/2. Generally, trains don't collide. We have an anti-collision system. So when the distance becomes a certain minimum value, right, both the trains' power supply gets cut off. So A decelerates with A and B accelerates with A by 2. The question is now, if these people don't accelerate fast and decelerate fast enough, there is a chance the trains will collide. So find the minimum value of A to avoid collision. Let's get this thing. It's an easy one. Now, if you see the question, we are talking about two trains and we're talking about two trains ka beach ka distance. We want two trains not to collide. That's the biggest hint. You're always talking about two trains. Means you're dealing with more than one particle, and generally that's an idea. Remember the process. Step 1, choose your reference frame. Here there are two trains A and B. You can choose any one. For simplicity, since we all are on the same track, let's choose B. We are going to stop B. And then subtract the velocity, acceleration, and then use kinematics. Give it a try. Easy one. I'll give you a minute or two, then I'll show you. What is the answer? Let's see. 36 convert into meters per second. No? So step 1, keep everything in SI units. The train A, 36 kilometers per hour is 10 meters per 72 is 20 meters per second. Hope everyone remembers the conversion unit, 5 by 18. Train B is going with 10 meters per second. And this guy is accelerating with A by 2, and this guy is decelerating with A. So let's stop B. So we are going to study with respect to B. So if you want to study with respect to B, we need to subtract B ka acceleration. So means I have to add backward. See, when I subtract, think like this. I'm adding A by 2 backward. So I have to add A by 2 backward for this guy. I have to add 10 backward. I have to add 10 backward. So B will think, okay, I came to rest. I'm not moving anymore. But this train A is coming towards me with a speed of 10 meters per second now, 20 minus 10. This is your U relative, the initial relative speed between them. And this train is going backward with an acceleration 3a by 2. This is your A relative. And the distance between them is now S relative, which is 1000 meters. So this train is going to come, slow down, slow down, slow down, slow down. And to avoid collision, the train A should just stop here. That is, V relative is 0. Now, can you see? You have V relative, you have U relative, you have A relative, and S relative. Which equation fits the data? V relative square minus U relative square, the third equation, to A relative, S relative. So finally, the train stops. Relative velocity stops. U relative is 10 square. 2, right positive, left negative. That's our sign convention. 3a by 2 into 1000. This turns out to be a is equal to 1 by 30 meters per second square. It's 1 by 30. Now be careful here. When we say v relative is 0 here, v relative 0 implies velocity of a and b has become same. It doesn't mean a stopped. So that's a mistake some people do. They think v relative 0 means the particle stopped. Right? It doesn't mean. And it kind of makes sense also. Think about it. If b ka speed is more than a, can a can come from behind and hit b anytime? If b is going with 30 kilometers per hour and a is going 10 kilometers per hour, a can never chase b. It doesn't mean a is at rest. So be careful with that. V relative is 0. B thinks a came to rest. In the ground frame, it is not the case. Easy question? Yeah, next one. Let's see one more. So we'll start with an easy questions and then we'll bump up the level. Yeah, no, that's what we do every time. Next one. We have a building here. This we have done before, but let's try with relative motion and see. So we have a building of height 50 meters. So we have a particle A here, which we projected down with 20 meters per second. And we projected particle B up with 30 meters per second. So both are on the same line. So A and B are going to collide. Gravity is anyway there. So find the time and the position where they collide. Yeah, let's get this. Easy one. What about the position? Got an answer? Please type in the chat box to the co-host here. And don't worry about writing the notes, you'll get the PDF. So just focus on solving the problems and try to absorb as much as you can. Remember the process. The steps are the same. Step 1, choose anyone whom you want to stop. I will choose P. I can choose A also. I'll choose A. So let's study with respect to A. So A ka acceleration is G, B ka acceleration is also G. So I need to stop A. So I will subtract A ka velocity. That means I'll add A ka velocity 20 up. I have to do the same thing here. I will add G up. I have to do the same thing here. Now A will think, okay, I came to rest. I'm not moving anymore. And this B is coming towards me with 20 plus 30, 50 meters per second. And the acceleration A relative is 0. So A thinks B is coming with a constant velocity. Then using the equation S is equal to ut plus half at square, your regular kinematics equations. The distance between them is 50, the speed is 50, time is t, and this guy is 0. T is equal to 1 second. Now, one thing you need to understand, no matter whether you're in the ground frame or the relative frame, time will never change. Does that statement make sense? Think of like this. I'll give an example. Let's say you are there on the platform. There is another person on the platform. Okay? You both are going to meet. Now, there is a person see on the platform. He's watching you both, and I'm going in a train and I'm watching both of you. Now, if you both meet in 10 seconds, do you think C and I will see different times? The time taken for A and B to meet will not change because I am moving, isn't it? Meaning logically, so if I am running, why the hell will the time between you both will change? The time taken for A and B to meet will depend only on A and B. Whether you're looking from the ground, you're looking from a train, you're looking from a plane, that should not change the time for A and B to meet. That means in ground frame also the time will remain the same. So that is one important thing. So time in all frames will remain same. Whether you're standing on the ground, you're standing on A, you're standing on B, it won't matter. In any frame, the time will remain same. That means, let's go back to the ground frame. So if you come back to the ground frame again, because you're asking where will they meet? So now the person is standing on the ground. So this guy is looking at both A and B. A is coming with 20 meters per second. B is going with 30 meters per second. And don't forget, no gravity is there because you're looking from the ground frame. So I'm just looking at the displacement of B in 1 second. So displacement of B will be 30 into 1 plus half. Remember, up positive, down negative. Gravity is pointing down, so it is negative. We keep the convention simple. Up, anything that is pointing up is positive, anything that is pointing down is negative. So these two guys are going to collide here at a height of 25 meters. Is that making sense, everyone? So once you got the time from the relative frame, you can just get back to the ground frame and find the distance. Are the steps clear? Again, I didn't teach you anything new. The only new thing that I taught you today was whomever you want to stop or study with, take his velocity and acceleration and subtract. Once you do that, the question becomes a regular kinematics problem which you have done before. And then just solve. Clear? Any doubts? Anyone not convinced with anything particular here? Please ask me. Devansh, Jainil, Arnav, clear with this? Niharika, Purvaja, Pratik, Vignajit, Ojas, Lakshita, clear with this? Great. Let's see one more. So we have X and Y axis. We have two particles here. Let's say this person A is there, is going with speed U. This distance is 2D, 0. This person B here is at 0, D, and this guy is also going with speed U. Now you can clearly see here, when B comes to the origin, A is still somewhere here. When B goes here, A will come to the origin. That means A and B will never meet. So if you can't meet them, what is the minimum distance between A and B? Find the minimum distance between A and B. Let's get this. So we have two particles A and B. One is going along X and one is going along Y. Both have same speed, but their coordinates are different. A is traveling from 2D and B is traveling from 0, D. So they will cross each other, but they're not going to meet at the origin. So find the minimum distance between them. So for example, listen to this thing. If I show you the path, initially this is the distance between them. Then B will come here, A will come here. This is the distance. Then this is the distance. Then this is the distance. Then B will come here, A will come here. This is the distance. This is the distance. This is the distance and this is the distance. You're getting? So that means if you look at the distance, initially it decreases and then again it increases. That means somewhere in the middle, they are the closest. Let's give it a try. And the first option will be D, which will be your -1. in case if someone think that is the answer. Try. You got 2-3 minutes. Try. Everyone should give it a try. It's okay to get a wrong answer. At least get a wrong answer, but give it a try. Who am missing? Again, remember, the steps are still the same. There are two particles A and B moving. Choose anyone you want to stop. Take his velocity, subtract from everyone. Then one guy will come to rest and one guy is still moving. Now the problem has become from two particles moving to one particle moving. With that point, relative motion is over. Now you have to use your kinematics and solve. That's it. Once you do that, once you choose a frame and subtract it, relative motion concept is done. So step one, we have to stop someone. I will stop A. And don't forget the coordinates. It's 2D, 0 and 0, D. So we are going to study with respect to A. So step one, stop A. So subtract U backward and subtract U backward. When you subtract, put U to the right side. Abhinav, you got quite a big value, right? Logically, Abhinav, what you got? When B comes here, A comes here, this distance is D, isn't it? Isn't that smaller than what you got? Okay. Now what will happen when you do this? Now listen carefully here. This person A will come to rest. A will say, okay, I am at rest now. But this person B here is going with U this way and it is going with U this way. That means he will go like this. In a straight line at an angle. This is the path of B as seen by A. Now A starts thinking B is going at an angle. And since that is U and this is U, we can clearly see this angle is going to be 45 degrees. If that angle is 45, this angle is 45, and this angle is 45. That means if you look at this distance here, this distance would be D, and this vertical distance is also D, because there's a coordinate is 0, D. Now you tell me, what is the shortest distance between a point and a straight line? If you have a point here, and if you have a line like this, what is the shortest distance? This. The perpendicular, isn't it? The shortest distance between a point and a straight line is a perpendicular distance. That means from point A, if you're going to drop a perpendicular to the path, then this is your D minimum. If this is D, This distance is also d. Because A ka coordinate is 2d, therefore the d minimum is given by the d sine 45, the opposite side, which is d by root 2. That's your answer. Once you stop A will think B is going in a straight line. So the shortest distance between a point and a straight line is a perpendicular distance, and done. You get just geometry. If you actually try to do this in the ground frame, you have to actually use maximum minima. You have to find the coordinates as function of time t, then get AB in terms of time, and then do maximum minima. That goes quite long. But this thing, when does this occur? This is actually happening at this position. A has come here, d by 2 comma 0. B has come here, 0 comma minus d by 2. At this point, you're getting the d minimum. In the ground frame, this is how it looks. Getting it? This you can't get it directly. You have to use maximum minima to solve this if you want. But this way you can figure out much faster, saves you a lot of time. Or else you can figure out the time from here and then you can do. The story is still the same. But in the ground frame, this is what is actually happening. This minimum distance occurs when A and B are at a distance of d by 2 from origin. Do have a look at this.
Sir,
Yeah.
so how do we know the angle is 45 degrees?
Interesting question. What do you think it should be? Let me ask the other way. What do you think it is then? That's an important question, right? It should be always that way. You think it is wrong, then you must have thought about something else. What did you think? बोलो ना कुछ भी. What do you think? What do you think it should be? I can't hear you
Why
properly.
can't it be 60?
ना तू बोलो ना. So what it should be?
It can be any other angle. Why
Why it can be any other angle? Why it is any other angle? There is a there. Look at there properly. It is there. Exam I won't be there beside you to tell you the answer. It is there clearly why it is 45. So let me ask you this way. Can you tell me B ka velocity in vector form? I cap, J cap form mein, can you tell me B ka velocity? Tell me, is there any component in the x-axis? Hello? Hello, you're there, you got disconnected. Anyways, it's the next question, we'll get back to him again. I hope rest of you understood why it is 45. Let's see, when Pratik comes back, we will see why. Let's see in the meantime a better question. So we have two buildings. Let's say height of the building is h1. Height of the building is h2. Distance between the buildings is d. So there's a particle A here, which is being projected with u1 at an angle theta1. And there's a particle B here, which is being projected with u2 at an angle theta2. Lot of variables. First question, find the minimum distance between them. Gravity is anywhere there. Find the minimum distance between A and B. Now, this guy is going to go like this. This guy is going to go like this. So at some point, there's a minimum distance between them. Projectile motion and relative motion. Find the minimum distance between A and B. Second one, find the condition if I want A and B to collide. Matlab, I want these two to collide. ठीक है ना प्रतीक, let's see another class I'll show you. Find the condition, meaning there is a relation between this u1, u2, theta1, theta2, d, h1, h2, everything. If A and B collide. See na Pratik, I'll just help you out here. Here it is there, record answer. This component is u, this component is u. If your x component and y component are equal, then what is the angle between them? Tan theta is opposite, which is inside. U by u, which is 1. So tan theta is 1 is theta 45. Yes. Now I hope you know why it is not any other angle. Because there's a horizontal and vertical component, both are equal. Next one. Let's give this a try. I hope the question is clear. We have two buildings, H1, H2, distance between the buildings is D. Both are projected with U1, U2, theta 1, theta 2. Find the minimum distance between them. This would be a good advanced question. And find the condition for them to collide. Try, you got 3-4 minutes. Again, remember the steps are the same. For simplicity, let's do one thing. I'm going to stop A. So you also try to do that so that we get the same equations. I'm going to stop A. Step 1, out of both of them, stop any one. I'm going to stop A. You can stop B also. Kuch wrong nahi, you'll get the same answer, but I'm going to stop A and show the problem. So it will be easy for you to refer. Step 2, once you stop after that, take the velocity, subtract, and you'll get the A will come to rest and B will move. Now it is easy to study because only one particle is moving, the other guy is at rest. And then you have to use your kinematics and geometry. Let's see. Give it a try. Anyone not clear with the question? Anyone didn't understand what's happening? Anything not clear? Please ask. If you didn't understand the question, it is my fault. Don't know how to do that's totally fine. Give it a try. I'm there to explain. Just give it a try and get some water and come. Let's see. Answer is not a simple one. It's a little complex. Try. I'll give you another minute or two, then I'll show you the steps. Let me show you the first step. Let's see whether you got the relative velocity same. Step 1, I'm going to stop A. Like I said, it's completely arbitrary. Could have stopped anyone. So before stopping, divide the velocity into components. So this guy is u1 cos theta 1. If you see, right, every equation I'm trying to put as pictorially as possible, try to draw as many pictures as possible. Because when you put a picture, right, it is more easy to figure out what is happening. We humans have a tendency to understand things when it is a picture than an equation. See, when I said V, A, comma, B, you understood what it means, but a picture made more sense. This was u1 sine theta 1. This was u2 cos theta 2. This was u2 sine theta 2. You also have acceleration g, and you also have acceleration g. So you want to stop A. Means I need to subtract, or I have to add u1 cos theta 1 backward. I need to do the same thing here also. Whatever I do to A, I have to do the same thing. I need to add u1 sine theta 1 downward. I will do the same thing here, u1 sine theta 1 downward. I have to put g upward here. I have to put g upward here. I hope you guys did the same. Then, once I did this, A thinks, okay, I came to rest. This B here now has a velocity u2 sine theta 2 minus u1 sine theta 1. They do subtract, and the horizontal would be u1 cos theta 1 plus u2 cos theta 2. This would be the path. So it goes in a straight line, and if you observe here, A relative is 0. This is what I wrote in the beginning. The motion of one projectile with respect to another projectile is a straight line. This is your path. This is path of B as seen by A. Straight line. Right.
Like the velocities u2 cos theta 1, u1 cos theta 1, they are like in the left side now, so we will take by convention it to be negative.
Yeah, you can do that, but right now you can do that, but you don't require here.
Okay.
No, till now I didn't use anything like that, not to use convention. If I use the equations I needed, right now I'm not using it. Okay. Now Pratik, can you tell me what is this angle? Tan alpha will be what? The opposite velocity Vy by Vx, which is u2 sine theta 2 minus u1 sine theta 1 by u2 cos theta 2 plus u1 sine cos theta 1. Is that fine? Then from here, if I drop this thing, let this angle be beta. This height would be the difference in height h1 minus h2, and this horizontal distance is d. Now this comes from geometry. Tan beta is the opposite side, h1 minus h2 by d. I'll show it in the next page. So what is the minimum distance? So you want, this is the point, and the red line is the path. This is the perpendicular distance, isn't it? This was your d minimum. There, I gave you all the data. Can you try again? I'll give you 1 more minute. There, I solved everything. I give you all the data. Now, can you try? You got 1 more minute. Give it a try. Anyone not convinced with anything that I did here, please ask me. Subtracting the velocities or the angles, the components, anything that you're not convinced. Puruja.
Sir, if we subtract u1 sine theta 1 from u2 sine theta 2, comes in negative, then A will see B is going niche.
Yeah, matlab then this will be like this, and it will be like this.
Yes, sir. So
Fine, na?
it
The
will
symbols
be
will take care, na? Dekho na. In that case, alpha will come negative.
Yes, sir.
So means alpha is not on the top, alpha is below.
So the answer will be the same.
The answer will take care of it. You don't worry about
Okay.
it. Since like what you're saying, right? Since everything is variables, we don't know. So you start with an assumption. I took alpha up. If alpha comes negative, means you took a wrong direction. You took this as alpha. In reality, this was supposed to be alpha. Meaning, if I give you numbers, so alpha, for example, you got alpha minus 30 degrees. Means what?
Yes, sir.
It is going down with
the
30.
same alpha.
Yeah. Yeah, what you're saying is that the sign will take care of it. We need not worry about that. When we don't know which one is bigger, you assume and you start, the signs will take care of themselves. So, if I look at the geometry here, this was A. This is the path of B as seen by A. In reality, B is going in a parabola, but A thinks that it's going in a line. This triangle, this angle was beta, meaning this angle should be alpha minus beta. Agreed? Because this total angle was alpha. So the difference in angle is alpha minus beta. So from point A, the minimum distance will be the perpendicular D minimum. This point was AB there. So from here we get AB is root over h1 minus h2 whole square plus d square, Pythagoras theorem. Because this height of the difference is h1 minus h2 and this distance is d. So from there I got AB, the green cut triangle, just dark it up. This triangle we're talking about. And therefore the D minimum will be AB sine alpha minus beta. Alpha and beta will come from here. Like I said, since I gave everything in variables, it looks complex. Numbers are given, it would have been easy. That's your AB cut distance and that's your D minimum in terms of alpha and beta. Now, for the second part, if they want to collide, tell me one thing, if two particles meet, what is the minimum distance between them? 0, right? If A and B collide, then D minimum should be 0. That is, sine alpha minus beta is 0. Therefore, alpha should be equal to beta. Or you can say tan alpha is equal to tan beta. So this thing turns out to be ut sine theta 2 minus u1 sine theta 1 by u2 cos theta 2 plus u1 cos theta 1 is equal to h1 minus h2 by t. That's your condition for them to collide. Both the questions are related in that way. But you can do this thing much faster without finding D minimum. Let me show that in the next page, but have a look at this. This was your D minimum, and that's your condition to collide. Any doubts on this?
So,
Yeah, bolo na.
sir, but if this was an actual question, then in the options we won't have alpha and beta, right?
So they'll directly ask you condition to collide.
Okay.
And
Okay.
they'll ask you find the condition to collide. I won't ask you the minimum distance.
Okay. All right.
Yeah.
Or we can also find it in terms of D and H1 H2, right?
You can do, but the answer will be quite bad. Sine alpha minus beta is pretty bad.
Yeah. Okay.
Clear with this? Everyone got the steps? Now, if you just want to find the condition to collide, you can do it faster. The steps are the same. Stop A. So we are studying with respect to A. So A comes to rest here. Now this guy vertical component is u2 sine theta 2 minus u1 sine theta 1. u2 cos theta 2 plus u2 cos theta, sorry, u1 cos theta 1. Now, let me ask you this question. If, let's say, you're standing somewhere here and I'm standing somewhere here, and you want to meet me, how should you walk? Can you walk like this to meet me? Can you walk like this, or should you walk like this? Means if you're going to come and meet me, shouldn't you walk straight towards me? So, since it is going in a straight line, for B to go and collide with A, the path should pass through A, isn't it? Does it make sense? So, for A and B to collide, path of B as seen by A should be along AB. That means indirectly you're telling this angle, let's call it something gamma, because you already used alpha and beta, and this is H1 minus H2. Basically, alpha become equal to beta. This is D. So we can say tan gamma. So you'll get gamma from two conditions: the velocity, u2 sine theta 2 minus u1 sine theta 1 by u2 cos theta 2 plus u1 cos theta 1. This also should be equal to tan gamma, which is difference in height by distance. Isn't that the answer we got here? So basically alpha become equal to beta. So both alpha and beta are same. That's what we proved here mathematically, but this was more intuitively faster. Is that clear, everyone? So the question is just condition for collision. You need not do the D minimum, alpha, beta, that is complex. Directly take the relative velocity and that path should pass through A and B and you're done. Please have a look at this. Anyone confused with anything here, please ask. Now, suppose if I ask you vector condition, we want to find the vector condition for collision. Again, now if you see, we are going more into mathematical. This is how always you should learn. First thing, learn it in a very simple form, diagrams, picture, keep it simple, like you're learning, you're like a kid. But as you go forward, right, make it as complex as possible, as mathematical as possible. Then you'll actually understand the deeper meaning of it. You should have both the sides. So if you see the vector condition, So pictures and all are good for understanding. But then when things get really complex, pictures sometimes they don't help. So vector condition for collision is this. Now think about it. So if you have 2 points here, A and B, this is the statement there. Relative velocity just now what we proved. If you stop A, then A should think the B is coming towards me. That means the relative velocity vector and the relative position vector, that is AB bar and VAB bar, velocity of A with respect to B bar, both should be opposite to each other. Must be anti-parallel. That means if A is somewhere here and B is somewhere here, if this is your position vector, RAB, then for them to meet, this should be the velocity vector, opposite direction. What happens if both are in the same direction? If both are in the same direction, that means A is going away from B. Why will they meet? They're actually going away from each other. So this is V1 bar minus V2 bar. Since you want only the direction, we have to take the unit vector. Mod V1 bar minus V2 bar is minus of R1 bar minus R2 bar by mod R1 minus R2 bar. Since you want the vectors to be anti-parallel, we need the direction. This is the direction of relative velocity, the unit vector. This is the direction of position vector or relative position. This is a mathematical condition for two particles to collide. You could have applied in the previous question, you would have got the answer. Please have a look at this. Isn't that what you did here if you think about it? When you took A to B, this was the velocity vector and this was the position vector and both were opposite. They were on the same line. The minus sign is important. If the minus sign is not there, that means both are in the same direction. That means the velocity, the position vector will keep on increasing. This minus sign is important. That negative indicates distance between them is decreasing. So when you're meeting, the distance should decrease. Is this clear, everyone? Clear? Let's see one more. Can I go ahead? Vihan? Clear? Surya? Nikhil? Devansh? Daksha? Clear? Ahana? Lakshita? Clear with this? Pratik? Puruja? Going ahead. Arnav? Arya? Clear? Great. Next one. Let's see how to cross a road. Top view. We got a road here. The width of the road is 4 meters. And we got a bus here, which exactly fits the road. So bus ka width is also 4 meters. It's a top view seen from a drone or something. The bus ka speed is 4 meters per second. Now at a distance of 4 meters from here, everything I took it as 4. You're standing here and you want to cross the road. Okay. So bus fits the road. moves with 4 meters per second. So at a distance of 4 meters, a boy tries to cross the road. Walks with speed u and crosses the road safely. Obviously, we want him to be safe. So the question is, now see, if he runs really fast, तो कुछ problem नहीं है. But there's a critical value there. Find u minimum so that he's crossing safely. Find u minimum. He can run with 100 meters per second, so he'll just go off like this. But if he starts walking with 1 meter per second, he will die. 1 meter per second. God. Try. Yeah. If you got 4 meter per second, congratulate yourself, you got a -1. Now let's see how to solve. Greater than 4 meter per second. So let me ask you one question. If this is you, how many of you actually cross the road like this, Ray? Or do you cross the road like this? I never told you that you have to cross the road in a straight line. Getting it? So just to give a little help, start like this. Let the person go with you at an angle theta. Start like this. Because you don't know, right? How is he crossing the road? Did I tell you he's going straight? All that I asked is minimum speed. वो कुछ भी कर सकता है. हाँ, but if you insist ना, नहीं sir, वो straight जाएगा, ठीक है, then prove theta is 0. If you're going to say he's going to go straight, then prove theta is 0. You don't make an assumption. We are not an astrology class. We don't do, all Shudra Pujas and all to get answers. We don't do black magic. We have to prove mathematically. So if you think it is going in a straight line, then prove it. But if you think about it logically, no one walks straight. You get scared of the bus. You actually go ahead at this thing. Actually, it kind of makes sense. The question was not to cross the road in the least time. I don't care about the time. Take more time, but cross the road with a minimum speed. Try. It's a good one. This thing was a previous year question. I just changed the numbers. It's a good one. So just to give an idea here, so we always start like this. Biggest problem is we start with assumptions. We should always be in this thing. Can't we wait for the bus to pass and walk? Yeah, that is one thing we can do. So that's not a problem. We can do that. So you also can wait for 2 more years to write your JEE exam. So instead of giving in 2026, you will give it in 2028. बस इतना ही डिफरेंस है और कुछ प्रॉब्लम नहीं है. See, you don't like that. So that is a problem. Even the boy doesn't want to do that. So let him go with speed u and theta. Right, Ahana? Yeah, I know. But let's see. Let's focus on the problem now. So what we do, we have to stop someone. See, the story is pretty simple. You see two things moving. Meaning, see, this is how I know it's a relative motion problem. I see two things moving. I don't know what to do when both are moving at the same time. It looks confusing and irritating. Stop one of them. One guy will come to rest. Then only one person will move. Now your life looks better. Isn't it? That is what I think every time. And that is how I know, boss, ये relative motion का problem है. And Vihan, theta is not given. You need to figure out. Theta is a variable. Clear? So I will stop the bus. So how do I do this? I need to stop the bus by giving 4 meter per second backward. Means I need to give the boy also 4 meter per second backward. Now what happened? The bus came to rest. Now the driver in the bus will think, okay, I'm at rest. Now this boy here who's standing at a distance of 4 meters, look at his velocities. The vertical component is u cos theta. The horizontal component is 4 minus u sine theta. Now try to understand, this is the velocity as function of theta, meaning when boy can choose go at any angle. If the boy decides to go at 0, 1 degree, 2 degree, 3 degree, 5 degree, 20 degree, 30, 40, 70. So for different angles, he will be going at different paths. So now for different speeds, this is what happens. If he goes with a very small speed, so what will happen? The velocity will go and hit him here. Getting it? If he walks very slowly, this is what the bus driver will think. The boy is coming and hitting here. If the boy goes little fast, he will come and hit the here. If he goes little fast, here. Now, if he goes with a particular minimum speed, the boy will just miss the bus. The boy will just avoid the collision. So these are different paths of the boy. Meaning, if you go with different speeds, meaning so if u is 0, what will happen? If the boy is not moving, the bus will just come and hit him. So these are different paths of the boy as seen by the driver for different speeds of u. If he runs really fast, the path will look like this. So the green color one, this is the path where he just avoids collision. So that is your minimum speed. Means when he goes with the minimum speed, he will just graze the bus ka edge. So this should give you your u minimum. Is the diagram clear, everyone? Now, so same thing, let me put it here. So this is your bus. This is the boy. So we are considering the minimum path. So he's just going to miss the bus. Fair enough. And the vertical component of velocity is u cos theta. The horizontal component of velocity is 4 minus u sine theta. Right? And this length of the bus is 4 meters. This distance is also 4 meters. That means this angle is 45 degrees. I hope that is clear, everyone. The vertical is 45, the horizontal is 45. If that is 45, then tan 45 is v vertical by v horizontal, which is u cos theta by 4 minus u sine theta. And tan 45 is 1. So we get u cos theta is 4 minus u sine theta. We ended up with u is equal to 4 by cos theta plus sine theta. This is not the answer. What is this then exactly? This is the velocities of the boy for different thetas. Meaning if the boy decides to go with 1 degree, you'll get this speed, 2 degree, this speed, 3 degree, this speed. Now among all these angles, there is one angle which will give you the minimum speed. is the speed of the boy at different angles. So the boy actually has to choose two options. You have to choose a speed, you have to choose an angle. And we know from trigonometry in max, a sine theta plus b cos theta. I hope you know this thing. The maximum value is root over a square plus b square. So in our condition here, sine theta plus cos theta is always less than equal to root 2. Therefore, for u minimum, what should happen? The denominator should be maximum. For u minimum, the denominator should be max. So the minimum speed will occur when sine theta plus cos theta becomes root 2. Their answer is 2 root 2 meters per second. And this angle is 45 degrees. So the boy is going with a speed of 2 root 2 meter per second at an angle of 45. That is the safest and the minimum speed go option. Vihan, you got that angle button. After that, you are stuck. Again, let me show you what I did the whole thing. Listen. So step 1, what we did, the first step is assuming the boy is going at an angle. If you take it straight, the question is gone. Because I never told you he's going straight. He can go any way he wants. And the only option is you have to have minimum speed. So I took u and theta, then I stopped the bus, then I got the velocity u cos theta 4 minus u sine theta. So for different values of u, I get different velocities. Among all these velocities, there is one velocity where you will just safely cross the road. That is a green line, right? Because range is, Abhinav, what you're talking. Don't just, talk any nonsense. That will actually create you problems in the exam. Understand whether it makes sense or not, because exam you're going to do the same mistakes. 45 degrees maximum range is for what? Got it, na? Yeah. So don't mix up everything like that. Because if you mix up everything like that, in the exam you're going to do the same blunders. 45 degrees for projectile. Here, no one is going in a projectile. Everyone is just walking with constant speeds. So, and then we took the green color ka path. This is 4 meter given. This is 4 meter given. So this angle must be 45. So the two velocities also should make 45. But then we got a problem. We got velocity in terms of theta. Theta, I don't know. What this is trying to tell you is, if the boy decides for an angle theta, let's say 1 degree, 2 degree, 3 degree, you get different velocities. Among all these velocities, there's one which is a minimum. So for that, we have to do maximum minima, or you can use a trigonometry to say this is the maximum value. Have a look at this.
Sir, but we didn't take the velocity into account at all.
Whose velocity?
Sir, we have to find both angle and velocity, right? So we
No,
didn't
the
take
question is find u minimum.
Yes, sir. So we didn't take velocity into account at all. So
Whose velocity?
the boy's velocity.
What is this u cos theta and u sin theta then?
Yes, sir.
No, we are finding that u only, na?
Yes, sir. Yes, sir.
All clear with this? It's a good one. You guys should definitely try this on your own again. It feels like you got it. Trust me, you try this again tomorrow, you will forget half of it. So take a rough paper, see the question, and try it again on your own. Let's see one more. Now, this question is little different. You should have seen this once, or else you won't get an idea. So I'll show you this question how to do, and then I'll give you some homework questions based on this. So you can try. That will be a better way to approach. But let me tell you what is the question. Top view. We have a cat here. That's a beautiful cat. So, and this cat is running with a constant speed u. Cat ka speed is u. At a distance, there is a dog. This dog is chasing the cat with speed v. Now, how is this dog chasing the cat? Think of like this. Tell me this thing. Let's say if this is a bus, okay, and you're standing here and the bus is going away and you want to catch the bus. How will you run behind the bus? Do you run like this? You don't do that, right? You run like this, isn't it, to catch the bus? So if you ever seen a dog or a cat or chasing a rat or anything, this is what happens. After some time, when the cat has reached here, now if you look at the path here, the dog is actually going something like this. When the cat has reached here, the dog is here. The dog is looking at the cat like this. And the cat is going with you. After some time, when the cat reaches here, the dog is here looking at the cat like this. You're getting how it is? The dog is always looking at the cat and running behind it, meaning the velocity vector of the dog is always pointing towards the cat. Dog is always looking at the cat and running. It's constant speed. Huh? Speed is constant, direction is changing. Constant speed v. What it means is, that is, velocity vector of the dog is always pointing towards the cat. Next time observe this, huh? When a dog or a cat is chasing something, this is how they run actually. Or you can just go to a YouTube and search a video, leopard chasing a deer. You'll clearly see this thing. It's just, it's grazing like this. Now the thing here is, the cat is moving with speed u, again, constant speed. Speed u. The dog is chasing the cat with a constant speed v. And v is greater than u. Matlab, dog ka speed is greater than the cat. So definitely dog is going to catch the cat. The question is, find the time when the dog catches the cat. This is from a top view. All the speeds are constant. So eventually, right, the cat and the dog will be caught somewhere here. Take a minute or two, try to understand what is given, information, try to assimilate. But like I said, this is not a general question. Matlab, these kind of questions, you will see them, you should know how to do. Matlab, you should have seen this model at least once or twice. So I'll show you that one, and then I'll give you based on that homework questions. But take a minute or two and think whatever you think you can do, try. You have done this before, but you know how to do this thing. Because if you don't know how to do this thing, the next questions you'll not be able to get it. And who told you the exam they're going to ask you the same exact question? Like I said, this is like a base question. Let me show you how to do these kind of questions. Listen carefully. I'll explain you once. You can again think about that, what I said, and then based on this, I'll give you 2 homework questions. You try on that. So this is my cat. Just call it C. This is the dog. The cat guy is simply running straight, and this dog is chasing. And eventually they meet somewhere here. Let the cat be caught at time t. Now, during any intermediate stage, when the dog is here, the cat is here. If you look at this angle here, this with theta, this is the v cos theta is the horizontal component, and this is the v sin theta. This is the horizontal component of the dog velocity. Now, understand here, the theta is variable. Every instant that the dog is turning its head, so theta is changing. Now, since the dog catches the cat, at this point, the cat and the dog are there at the same place. I can say the horizontal distance traveled by the dog is equal to the horizontal distance traveled by the cat. The horizontal distance by the cat is how much? Speed u into time t constant. This should be equal to horizontal velocity of the dog v cos theta into dt. Why should you integrate? Because velocity is not constant. Because the speed is changing every instant, speed into time is distance, but if speed is changing, remember it is integral mod v dt. So this is the horizontal distance by cat, which is ut, is equal to horizontal distance by the dog. Horizontal distance are not total. Definitely dog is running more than the cat, but horizontally they travel the same. This is my first equation. Ut is equal to v is constant integral cos theta dt. Now we are stuck. I don't know theta, I don't know dt. I don't know how to solve that integral. This is step one. Generally, you see a question like this is the way to do. The second part. Now I need to do something to eliminate that cos theta dt. Any doubts on this page, please ask me. Second part. This cat is going like this. The dog is chasing like this. At this point here, the dog is looking at the cat. Cat is going with u. This is theta. This is also theta. So let's stop the cat. So this component will be u cos theta, and this component will be u sin theta. So if I study with respect to the cat, so the cat will think, okay, I'm going this side with u cos theta, and I'm going this side at that instant, okay, u sin theta, resultant is straight. This dog here is coming straight towards me with v. So how do I stop the cat? Take the cat ka velocity backward, u cos theta, and this velocity u sin theta, and this would be u cos theta, and this would be u sin theta. Now suddenly the cat will think, okay, I'm at rest. So think of like this. Let's say you're sitting on cat ka head and looking at the dog. So this is what you will think. So cat will think, okay, I came to rest now. This stupid dog is coming towards me. Now with the speed of v minus u cos theta, and this guy is actually responsible for them to meet, because this is the one who is decreasing the distance between them. This is responsible for decreasing the distance between the cat and the dog. And this other component here, which is u sin theta, this is responsible for rotation. So if you ask the cat, how is the dog going? This is how the path would look. This is the path of the dog as seen by cat. So if you're sitting on the cat head and look at the dog, this is what you'll think. The dog is running, takes a turn and comes towards you. Now from here, we can clearly see if that is the catch there. Let me make this little small. the initial distance between them is L. And finally, when they meet each other, the distance is 0. So we can write the velocity minus integral v minus u cos theta dt should be equal to displacement. Relative displacement. So relative velocity into time. So this is relative velocity. Into time is relative displacement. Why does it have a minus sign? Minus because the distance is decreasing. This velocity is responsible for decreasing the distance. Since distance is decreasing. So you end up with minus integral v minus u cos theta dt. The displacement final minus initial position. X final minus x initial. X final is 0 because they're meeting each other and initial is minus L. The final equation would be integral v minus u cos theta dt is equal to L. This is your equation 2. Please have a look at this. So you stop the cat at a given angle, somewhere in the middle of the problem, you stop the cat at angle theta. The cat will think the dog is coming like this at a curve. That is fine, but what I'm more interested is this velocity, v minus u cos theta. This guy is responsible for the dog to meet the cat. So v minus u cos theta into time should give you the distance between them, which is L. Is this making sense? So we got the data from 2 points. One, horizontal distance is same. Second, relative velocity into time is the relative distance between them. So we have 2 equations, 2 unknowns. So the first equation is ut is integral v cos theta dt. This was equation 1. And the second one was integral v minus u cos theta dt is equal to L. So from here, we can say this is v integral dt minus u integral cos theta dt is equal to L. And from here, we can see integral cos theta dt is ut by v. Take this and substitute here. There's no need to integrate here. This will be u ut by v is equal to L. V square minus u square into t by v is equal to L. We get time is equal to VL by v square minus u square. This is the time when the dog catches the cat. This is how you do this problem. Solving equations is fine. Major thing is these 2 steps. This page and this page are the important ones. Please have a look at this. You guys should definitely do this again. If you're confused, you should watch the recording again for this part especially. I'm pretty sure you'll be confused. Meaning right now you feel like, I got it, but you will get confused. But got the idea? Now, how to get out of the confusion? You do something based on this. This would be a first homework question, which we will discuss in the next class. Definitely try and come. If v is equal to u, matlab if the dog ka speed and the cat ka speed is equal, can the dog catch the cat now? No, right? The dog can't catch the cat. What will happen? Eventually, cat will be running like this and the dog will be behind this, isn't it? And the distance will never decrease. So the question is, if the dog can't catch the cat, then find the minimum distance between cat and dog. This, whatever I taught you now, that with that you can solve this thing. Second homework question is a little more weird. Now, if you see the dog ka speed is constant, but dog ka angle is changing. So find the initial acceleration of the dog. That when dog is accelerating, if velocity is changing. Initial. acceleration of the dog. This is what makes these questions this would be a proper advanced paragraph question. Even at your seniors level, this is a pretty tough one. So if I ask you this as an advanced question, the first question which I taught you right now, right? This is a standard Irido question. This is from Irido. This was a standard model. Matlab, people know, okay? Meaning, kahi bhi dekh lo, you'll get this thing. These two questions is modifications. So we took a standard question, which itself is weird. And based on that, we put more complications. So make sure to try this thing. If v is equal to u, then the dog can't catch the cat, then find the minimum distance between them and find the initial acceleration of the dog. So definitely try this thing. Make sure to go through this. We have already touched 63 problems. Like I said, relative motion, these are the tough ones. The Rain Man, Riverboard, that is actually a joke. These are the main ones which you should be doing. So next class, when we catch up, we are going to do one more problem where particles are chasing each other. That's a pretty good model. And after that, we'll go for Rain Man and Riverboard thing. Those are the standard ones. I think it should take another 1.5-2 classes, and then we'll go for graphs. So with that, we'll be wrapping up the kinematics there. So do definitely try all these problems, right? Especially the last 3-4 things which we did. Still confused, somewhere you're confused, you can definitely ask in the next class anyways. But do try the homework problems. Okay, so with that, we'll wrap up for the day. So any notes in today's class, anything else you can stay back and ask, or else you're free to leave. So